So very warm welcome from the two of us as well. Thank you for the introduction, Andre. And thank you everyone at Lingo Systems and Stefan and Valeria in particular for setting this up and for having us. Very happy to be here. My name is Philipp Ursprung. I will do kind of the introduction to our project that we're presenting here. Then my colleague Raimon, who's here with me, he will go into the details of the actual project and the technical aspects. And I will wrap up with a bit of an outlook. And then, of course, we're happy to take questions and enter a discussion later on. So basically, I want to start with just a few words about Apostroph Group for those of who are not familiar with us. We are one of the full service language service providers focusing on the DACH region. We have several offices and around 160 employees in total, spread across Switzerland and Germany. We're very much, as probably everyone these days, we're very much technology driven. And one aspect that is very important to us and that we put a lot of focus on is data and information security. That is, it's a bit different in Switzerland than in Germany. That makes it an interesting topic. It's very important to a large part of our clients, which consist of pretty much all industries. But when I say data and information security, I mainly think of the public sector, government, of course, financial institutions, also particularly over here in Switzerland, and maybe life sciences as verticals that we work in, where this is very important. And this is an important kind of basis for our use case. We gladly have an internal language and AI engineering team, which is Raimon is part of. They're over here in Switzerland. So we have capabilities to work on such projects, which is very nice. And also important for the following is that we mainly work into the target languages that are the Swiss national languages, plus a lot of English. And of course, German English is very important in the German market. So the actual Apostroph project, and we call this Apostroph. Apo is, of course, the reference to Apostroph. So who's using this? Who built this? And suggest is basically what it does to the end user. It's an LLM-based solution that suggests changes. And we just have a quick summary of where we started with this project. So when LLMs came about, and in particular open source LLMs that can be where work can be done with, we wanted to give this a try and focus on a solution that we can deploy locally in our environment, in our own Switzerland-based infrastructure. That's important for the data security aspect. So we wanted to, and there's great use cases, of course, based on ChatGPT and OpenAI and their APIs. But it becomes a little tricky when it comes to data security often. I mean, that has been mentioned many times in different forums, of course. So we wanted to make something work, not relying on OpenAI APIs, basically, and have this run and also in a performant way in our own infrastructure. And it was important to us to get this, to actually really have a real life scenario. So something that brings value and is not just trying out technology, which is also important in such a project, but to really focus on what will this be good for. And we're very much a high-end quality LSP. We focus on quality translations, and we wanted to give something, a little assistant, some support to the many linguists working for us on the high quality translation. So something they could really do and could really use in their day-to-day business and is relevant to them. So it's tailored to the languages that I mentioned before. It handles these languages best, and it must be implemented in the tool and the workflows, the toolkits and the workflows that we work in. That is most important. And that's sort of the basis for the insights that we will now get from my colleague Raimon. he's taking over from here.
So, first of all, I'd like to talk a little bit about the motivation behind Apostroph. The fact is that in Trados, the existing QA checkers, such as spell checking or the antidote verifier, have a certain restricted range of errors which they can handle. So we would like to leverage AI to increase the range of the potential errors that we're handling. The inspiration behind this is, of course, ChatGPT. So you can, for example, if you want to double check a sentence that you want to correct, you can ask ChatGPT, please, correct the sentence, and ChatGPT will give you a potential correction. So how does this actually show up here? Oh, sorry, 1 second, we are back. So I'm gonna sit down really quickly. So I'm gonna lower the table here. So how does this actually show up in Trados? Well, you're going to run the plugin first, and the plugin is going to send the segments one by one to a Switzerland-based server with a GPU. The segments in Trados will then be corrected by the LLM that's running on that server, and they will be sent back to the Trados plugin. If there is a mismatch between the original text that was sent to the server and the text that's returned, the corrected text, we are going to display this mismatch as a little red icon there. And hovering over the little red icon will allow you to look at the suggested correction. So a little bit more about the ML background development, because it's actually not as simple as simply taking an LLM from Hugging Face and telling it, please correct each segment one by one. The issue with LLMs, when you're, for example, asking them, correct a segment, they really like to introduce changes. They really like to be creative. And because of that, if you simply take a wholesale LLM from Hugging Face and ask it, do this correction segment by segment, you're going to end up with far more unnecessary corrections, which are going to take away the attention and the time of the translators that are using your plugin. So in the left case, which is the case we want to avoid, we are in a high recall case, which means that all of your mistakes are probably going to be corrected if you use wholesale LLMs, but also many unnecessary corrections are going to be introduced. And we would like to go to a high precision case, which means that we would like very few mistakes to be identified, but each time that a mistake is actually identified by the LLM, we can say with high likelihood, this was an actual mistake in our document. This way, we don't waste the time of our translators and our end users. So we have a 4-step process in order to achieve this high precision regime. We start by fine-tuning our LLM for linguistic tasks. We then find an optimal prompt, which is followed by adding context to the data that's being passed to the LLM. And finally, we have a post-processing layer. And we're going to look at each one of these steps and how they affect the overall result. So I'm not going to go over again transformers in detail, but they form the backbone of any modern NLP solution, right? Transformers sequence in, sequence out. For example, sequence in, please correct this text. Sequence out, a corrected text. The fine-tuning itself is not done on the whole LLM because we don't have the resources for that. We rather use the low-rank adapter method. So we only fine-tune a very small set of parameters, which kind of hooks into the parameters of our larger LLM. Now, the data that we actually use to fine-tune the LLM looks exactly like this. We have an instruction, we have an input, and we have an output. The instruction is a linguistic instruction, for example, summarize a text. The input could be a longer text, and the output could be a shorter summarized text. And our LLM has to construct the shorter summarized text by simply looking at the instruction and the input. But how do we source a data set of these tasks for fine-tuning? Well, we're going to be using GPT. So we use a modified version of the self-instruct pipeline. We first generate 200 seed tasks using GPT-4, which will then guide task generation for GPT-3. Why don't we simply use GPT-4 to generate all of our tasks? Well, because it's expensive and slow. And why do we need these guide tasks for GPT-3? That's because GPT-3's quality is not exactly up to par unless you give it examples of what exactly you'd like it to generate. Once we've gone through this generation, we have our data set of 100,000 tasks per language, and we use those to fine-tune 4 adapters. So here I have 2 slides which just repeat a little bit what I've said here, so I'm not going to actually go through them exactly, but the important thing is that we end up with 100,000 tasks per language. So we end up with 100,000 tasks for English, French, German, Italian. We use those to train 4 adapters, 1 adapter for English, 1 for French, 1 for German, 1 for Italian. And here you can see a little bit the breakdown of the tasks. We have some generic tasks, and we also have some specific linguistic tasks. Once we fine-tuned our adapters, we go on to prompt tuning. So when I tell my LLM, please correct a text, I can say this in many different ways. I could say, correct the following French text. I could say, look at this French text and fix errors. But how do I know which way of saying this to my LLM generates the best results? Well, I could use a grammar correction data set. So I could have a data set of sentences, correct sentences, and a modified version of these sentences to be corrected, which are sometimes modified with a mistake and sometimes are the exact same sentence as the correct sentence. And one thing that we can notice is that when we, for example, use an LLM to correct each sentence in our sentences to be corrected, we end up with a task that's analogous to a 2-class classification task, in the sense that in our sentences we can have, for example, 4 different cases. We can have the case that in our sentences to be corrected, there was a mistake, and we correct the mistake correctly using our model. This would be a true positive. We can have the case where there was a mistake, but the model has not corrected it. This would be a false negative. We could have a case where we do not have a mistake in the original sentence, but our model outputs an unwanted correction. This is actually what we're trying to avoid, if you remember the previous slide. Well, not the previous slide, but slide a little bit before. And this would be a false positive. And finally, we have a case where we do not have a mistake, and the model leaves the sentence alone, and this would be a true negative. And so for each prompt, you can run the prompt with the LLM over the entire data set, have a bunch of different cases, true positive, false negative, false positive, true negative, and build a confusion matrix. So for each prompt, you can have a confusion matrix. And I won't go through the calculation of the F1 score here, but simply know that it is a way that from the confusion matrix, you can extract the performance of the model. And so for each prompt, we have confusion matrix, we have an F1 score. So we simply generate a bunch of prompts which are a little bit similar to our original prompt, but which have some changes. We generate those prompts using GPT-4. For each prompt, we do this running it through the data set, getting the confusion matrix for it, and then extracting the F1 score. And we keep the prompt with the best F1 score. So here are the actual prompts that we found. I don't really want you guys to read all of them. All I would like to highlight here is the prompts are different for the different languages. Now, next we have the context window. I'd like to give you an example here. On the top right, as you can see, you have this French sentence, donc nous allons de ce pas manger, which gets corrected to donc nous n'allons pas manger. And this would be an erroneous correction. And this is because of the fact that the word pas can mean step in French as well as be a negation. And in the case that you don't give your network sufficient context, the network is going to infer, for example, oh, here we're talking about the negation, and is going to give you an erroneous correction. However, adding context, adding the preceding segment to the correction of your current segment will give the network enough context that it will make much more relevant corrections. Finally, as you can see here, what can also happen is that even when your network corrects the grammar in a relevant way, it may sometimes not keep your formatting intact. So we also add format guidelines which stabilize the output of the network and which reduce the effort of post-processing that we have. We have one final post-processing layer where we have exclusion rules, where we have ways to deal with heterogeneous formatting, where we have layers that double check our results. And this is all called the post-processing layer. We use all of these methods to maximize precision further and to have a more precision, to have a more precise method. Finally, I'd like to talk about the results. We have a synthetic document, synthetic in the sense that in the real world, most of the time, you are going to have a really imbalanced data set. You're going to have, most documents are going to have no errors whatsoever. And when there are some, it's going to be 1 or 2 in the real world context. So here we've introduced, we've taken a document, we've introduced 23 synthetic errors. And these synthetic errors are not detected either by the spell checker or by antidote. And we then, at each stage of development of our method, we computed the confusion matrix over our synthetic document. And we looked at how each step of development affected the results, affected our confusion matrix. So our goal here is to maximize the ratio of the green, the true positive, to the red, the false positive. We want as much green as possible, as little red as possible, which will increase the precision. So as you can see, with a fine-tuned, simple fine-tuned network, you're going to have a lot of false positives, which are undesirable, which simply take the end user's attention away from the actual important errors. Prompt tuning, even though it was a little bit of a complex step in our development, didn't yield actually that much improvement. However, as expected, adding context did give our network a huge boost in precision. And finally, one should not disregard the importance of post-processing your outputs, as those can one more time give you a boost in the direction that you'd like. So I think I'll give it over back to Philipp. You want it? I will, but once you're okay.
Okay, yeah, we also have a little live demo what this looks like in Trados in a minute. I will just continue with the outlook first. So basically, yeah, where we are with this. So it took some time to develop, as you can imagine from these steps, to actually meet our requirements, to make this relevant, to make this actually really useful in the languages where we operate and in the environment, which is mainly Trados Studio as main production tool, as main CAD tool. So we are here, and we can look at what is coming up in the future. So we are currently using Apostroph in a live test with internal users. We want to, of course, get all kinds of feedback from both project managers and linguists. So is this relevant? Is this helpful? Am I getting not too many false positives, as Raimon mentioned, was the goal and was also seen in the numbers that he just shared before. But also on performance, is it do I have to wait too long for a reply from the system, or is it fine? And of course, along these feedbacks, we want to improve. Then a big step will be to make this available to all our external linguists in the network, so they can use it directly as they translate for Apostroph. and for our end clients in the projects. Yeah, just generally improve the performance of this system. And I mean, yeah, it's could be that the next big thing is just around the corner and we don't know about it yet. And of course, new solutions, new LLMs coming out all the time, but focusing on what we have worked on so far. What we want to do is to add more information on the actual source language content to make the changes that the model suggests, that Apo suggests, proposes even more relevant. Also, of course, would be important to include terminology, be it industry-specific or customer-specific terminology to this very output. And yeah, just work more on the data, because the solution as such is here. So we've reached the goal to operate this in our environment, to make it performant, to make it relevant for our languages. But of course, performance can always be enhanced, and we want to do that by looking at yeah, relevant data sources that will actually help this process. And also, it's currently in Trados, as we mentioned. We are looking at integrating it into Translate 5, which is a second very important production tool for us, which is also something you will all hear about in a few minutes in some more detail, which I look forward to. And yeah, that will be our second step. Now, if we do have a minute or two, I think it would be nice to show what it looks like in Trados. I think we can take this minute or two. And I'm just changing applications and hope the sharing won't break. If it does, please let me know. Otherwise, I would hand back over to Raimon quickly.
So here we have another test document that we use. As you can see, we've already ran ApoSuggest on a few lines here. We've introduced some errors, but I'd just like to introduce a few more errors and let you have a look at, you know, how it actually functions. So, for example, here, elle peut toucher ses destinataires. We can put in the wrong form of c'est. You can put, for example, elle peut, let's say, elle peut renforcer vous, relation commerciale, and you can put in c'est toujours bien, and then you can run ApoSuggest, and as you can see, toucher ses destinataires, it corrects the form of c'est. Renforcer vos relations. Yep, that's also correct. And finally does correct the wrong form of say. Okay, that's pretty much where I'm going to leave off, and I'll give it back to Philipp, and thank you for your time.
So yeah, just to wrap up from our side, going back to the slides. Yeah, as we saw, and this was a very small example, of course, but it is actual errors that are not picked up by traditional spell checkers. That's important. It's very fast. And what we also saw, and I think it's important to mention, it doesn't actually correct the text as such. It does suggest, so hence the name ApoSuggest, because we want to keep the linguist in control, and rightly so, I believe. So it's something that assists the linguist, but it doesn't overrule the linguist. So that's why we saw these suggestions, but not the text being actually altered by the system. Yeah, so that was a quick glance, and that was an insight into yeah, a real life scenario project. Is something that we've done, and yeah, with that, I would like to thank you for your attention.